Welcome to this video on the ZNA Network Analyzer. In this video, I want to explain to you how we can perform intermodulation measurements on devices under test. In this example, we're going to be using an amplifier as our DUT. So we will start the measurement by accessing the intermodulation wizard, which we can find in the measurement menu. And then in here, we can see on the left-hand side that we can configure the ports that we're going to drive the two-tone stimulus. So in the ZNA, we have up to 4 internal sources, lower tone driven from port 1 and the upper tone from port 3 in this particular example. The important part is how we're going to provide the combination of the two tones for the two-tone stimulus. So in here, we can see there's various configurations that we can choose. We're going to use the coupler inside port 3 as an internal combiner for this application. And then port 2 is our receiving port, measuring the output of our amplifier. We can change the sweep type, frequency, power, delta F. So we're going to perform a linear frequency sweep in this range from 3 to 12 gigahertz. The base power, we're going to change that to minus 15 dBm because my amplifier under test has a minus 5 dBm compression point. So we want to be a little bit below that. We reduce our measurement bandwidth to 1 kilohertz. And then the step attenuator at the receiving port, we select this so that we make sure that our network analyzer receiver is well below the compression point. So 30 dB is about the gain of our device under test to ensure that we don't hit compression. And then finally, we select OK, and the measurement is now configured. So now I've connected the USB power sensor to the port 1, which is providing our two-tone stimulus. We can run through the calibration routine. At the bottom of the soft key menu here, we have intermodulation power calibration. We enter this menu, and the first step is that the power sensor has to be connected to the two-tone stimulus port. Here we run the calibration sweep, and then the network analyzer will use the measurements from the power sensor to correct both for the two-tone stimulus level and any cabling and external components that you have outside of the network analyzer. Now with the first 2 steps complete, the last step is that we provide a connection between port 1 and port 2 so that the network analyzer can calibrate the receiving port here at port 2. And we simply select Start Cal Sweep, and now the calibration sequence is complete. To gain a level of confidence with the calibration that we've just applied, over here we can select Add CW mode. And if I just move this down to the bottom, we can improve the resolution there a little bit by adding a few more data points. And then maximize. We can now see that both tones, the lower and the upper, have been calibrated to this minus 15 dBm power level. And just as a quick check, we can go into Use Cal and see what would happen if we turned off the calibration. So now all the correction has been applied to include the power cables and so on. So for the next step, we've actually connected the device under test, our amplifier, and now we're going to configure the intermodulation measurements and look at the performance of our DUT. We can see that the two tones now are at a much higher power level because we've got the amplification of the device under test, about 25 dBs. And in the top window, what we're going to do is add the measurement quantities. So back in the measurement menu, we can see underneath the wizard, we have the measurement parameters. So we'll start with main tone, where we can look at both the lower or the upper tone reference to the input or the output of the device under test. So here I'm going to choose lower tone. We have the intermodulation products. So you can see all the relevant products are displayed here. In this particular example, I'm just going to choose a 3rd order lower tone. And then the intercept points shows in exactly the same way. And here I'm going to show the 3rd order intercept point reference to the lower tone. And then finally, what we can do here is in the scale menu, we can auto scale all of these to a common scale. Let's just maximize that. And for ease to be able to read off the values. Let's just put a marker on here. And now we can see that at this particular frequency, around 3.75 gigahertz, we have a third order lower tone of intermodulation. It's around about minus 35 dBm. And then from that, we can calculate the intercept point. In this particular case, then that's around about 38 dBm. Now, as a final step, to get a little bit more information about the linearity of our device under test, we can add a power sweep measurement and see how those intermodulation products compare against varying input stimulus. Back in the settings menu here, where we see the wizard, we can take the settings that we've already configured and say copy to new diagram area, and then simply we change now the sweep type from linear frequency to power. And in this particular case, I'm going to ramp my power from minus 15 dBm start to plus 10 dBm for the finish, and concentrate around about 9 gigahertz for where the fixed CW tones will sit. Select OK, and we can see now what it's done. It's configured a new window underneath here, which I'm going to just maximize. And then we want to scale our traces in the same way we did before. So auto scale to a common scale here, pop a marker somewhere here, a couple of the markers, and maybe do search max. And we can see that at this particular point, if we're looking at intercept point, then around 3.75 dBm as an input power level, we're seeing almost 40 dB for the IP3. So in summary, we've seen how the Rohde & Schwarz ZNA network analyzer enables the user to make intermodulation measurements in a fast and convenient manner. The ZNA has up to 4 internal high-power sources for fast two-tone measurements, and the setup and calibration is simple and straightforward. The high intermodulation performance of the sources and receivers within the ZNA meets the demands of the most challenging applications. So thank you for watching this video. If you would like more information, then please visit our website.